Tangibilisco here, proprietor and operator of amateur radio station W1GV Whiskey. 1. Good vibrations. Here to describe for you the antenna that I would use for DX if I had to use a vertical antenna, and height was really no object. I could make it as high as I wanted without using a balloon or a kite to support it. In other words, we say for 40 meters, a half wavelength radiator would be roughly 66 feet long. A half wave electrical wavelength would be about one half of an electrical wavelength would be about 66 feet. And that's a good band to use as an example. Here, this tank circuit, this parallel resonant circuit, comprises a roller inductor with a tap that you can move easily, and a variable capacitor such that this whole circuit, the entire coil and the variable capacitor, can be tuned to the frequency that you want. In this case, let's just say 7.035 megahertz in the CW portion of the 40 meter ham band. You tune this to resonance right here, this whole circuit, and then you move this tap up and down until you get a perfect match to the 50 ohm coaxial cable that runs to your radio. Note the shield should be grounded at the feed point. You want to include a lot of radials to minimize the ground loss and also to enhance the low angle radiation that you will get from an antenna like this. Well, okay. 50 ohm coaxial cable. Does that look like the word coax to you? Looks like the word chukabakabaku to me. But anyway, it's 50 ohm cable to your radio. Now, this half wavelength radiator will in and of itself present a very high radiation resistance, and if you tune it to resonance, the ground loss will be quite low even without radials. And you will get a pretty low angle of radiation because this is in effect like a vertical dipole antenna, or let's say a ZEP antenna's radiating element. So most of the radiation will take place like that. But there will also be considerable high angle radiation, both from ground reflections and from directly into the sky. But if you add a lot of radials, what you're going to end up with is a very good mirror image of this radiating element down here. And you will end up with what they call a double ZEP, or two half waves in phase, turned on its side. And when you do that, you enhance the radiation lobes in such a way as to sharpen them and make them stronger in the horizontal plane like this, and to reduce the amount of high angle radiation to compensate for that gain that you get here, just like you would in an ordinary double ZEP. So, and I've done this, and in fact a tuning network like this will tune just about anything, even a piece of dry spaghetti. But if you do that and run much power, you can expect arcing to occur in this circuit. But who's going to do that anyway? The idea being that it'll match this high, purely resistive impedance to a purely resistive 50 ohm impedance, provided that you tune the circuit to resonance, the entire coil and the capacitor, and then you adjust the tap until you get a match to 50 ohm cable. It doesn't really have to be a very good ground in terms of soil conductivity, although of course the better the soil conductivity, the better the results will be. You should simply make the radials as long as you can and as numerous as you can, and you should bury them beneath the surface. One more consideration: this works by far the best on a level plane, such as you might find in East Dakota Territory, United States of antennas. So that's it in a nutshell. Oh my gosh, I committed a triteness. I hope Bill O'Reilly didn't hear it. Stan Gibilisco, W1GV, Whiskey 1, Good Vibrations, saying so long for now, and best regards, 73.